Welcome to this video lesson, which has some practice questions on what informations we can extract from a position time and a velocity time graph. For the first question here, it's asking us to use the following graph to determine the following. Just for extra set of information here, let's say everything is good to two significant figures in terms of the values. First, we want to find the displacement from 1 to 3 seconds. So this is a position time graph, so it shows position at different times. So position at time 1 here. Let's write some of these information down. So position at time 1 is 3 meters in the east direction. Position later on we'll need position 3. Position 3 is also 3 meters in the east direction. I think for the next question, we also need position at 6, which is right here. That's 0 meters. And imagine all of these are two significant figures. So actually, this is 3.0, this is 3.0, this is just the 0 is fine. And finally, for 8 seconds, our displacement, or sorry, our position is at 8 seconds. That's -2, I believe. Yes. So that's -2 meters in the east direction or 2 meters in the west direction. So we want the displacement. So for the first displacement, we have to take position 3 and subtract it, position at 3 seconds and subtract it from position at 1 second. So we also want to, it says determine, so we can show some work for this. So displacement from, I should say 0 because that's 0 seconds. 0 to 3 seconds is going to be d3 minus d0, and in this case when we do it, we get 0 meters in the east direction. For part B, might actually be a good idea to include the 0.0 because it's two significant figures and we're subtracting two values, and we got to use the least number of decimal places for this. For the second one, the displacement, we're looking from 3 to 6 seconds, so that's going to be position 6 minus position 3. And I'm pretty much taking east to be positive, and we get 0 minus 3, which is -3.0 meters in the east direction or in the west direction. And you can think about it differently too. You can just find a displacement by just saying how far you're moving. In this case, you're moving in the west direction from this point to this point, and you're going for 3 meters in that direction. So you can either show that or you can show the displacement like this, and that's the displacement from 3 to 6 seconds. And then for C, we're asked to find the displacement from 6 to 8 seconds. So that's position 8 minus position 6. Position 8 is -2, position 6 is 0, so that's -2.0 meters in the east direction or 2 meters in the west direction. Again, completely up to you in terms of how you're going to write the final answer. For average velocity between these time periods, so for average velocity, we have to use average velocity is slope between 2 points, or just the equation, so it doesn't really matter which method you use. In this particular case, I did make a boo-boo here. This is position 1 and this is position 1. It turns out to be the same because position at 0 second and position at time 1 is exactly the same. So that doesn't really change anything in terms of the final values, but I do have to change those. So So for part D, here the average velocity between those 2 points, so velocity between 1, 2, 3 is going to be the displacement from 1 to 3 over the time it takes for that to happen. And in this particular case, the displacement is 0, the time is 2, and in this case we get 0 meters per second in the east direction. And note that when you look at it as well in terms of the slope of this line, it is a horizontal line, and therefore it should have a 0 speed for the average velocity. For the next one, I'll do that maybe in a different color. Let's use pink. Average velocity from 0 to 8 seconds. So 0 seconds, we're here. 8 seconds, we're here. So we can find the rise over run method. And the rise here represents the displacement. And the displacement here from up here, it's 3. Up here is -2. So -2 minus 3. So I'll write that down. This is for part E. From 0 to 8 seconds is going to be either rise over run or displacement from 0 to 8 divided by time. It doesn't really matter. I'll write it as rise over run here. They're the same thing. The rise here is -2 minus 3. And the run, we kind of end here at 8 seconds and we start at 0 seconds. So our run is 8 minus 0. So that's -5 over 8. And if I plug that into my calculator, I will get -0.63 meters per second in the east direction. And I'm using 2 significant figures because my answer here is 2 significant figures. Sorry, my original values, 2 significant figures divided by 2 significant figures should produce something of 2 significant figure as well. I can't put the third one in there, and I just rounded 0.625 to 0.63. Outline the motion, or kind of like describe it in this case. We're giving a little bit of detail about it, so let's do part F here. Okay, what do we know about the motion? So first of all, in the very beginning, we know that the object is at position 3. As time passes, the object isn't really doing anything. So between 0 to 3 seconds here, the object is stationary and is to the east of the reference point. And we know this simply because this is the reference point and this is 3 meters east of it. So the object isn't moving, isn't moving, isn't moving, isn't moving. And then from 3 seconds all the way to 6 seconds, it starts moving towards the reference point. And since this is a straight line, it's moving at a constant velocity. So this is between 3 to 6 seconds. It moves west, it moves towards the reference point, and constant velocity. And finally, from 6 to 8 seconds, we can see that it keeps moving in that direction. It keeps moving in a constant velocity, but now it's moving away from the reference point. So it moves away from reference point at constant velocity and moves west. And we know it's moving west because if the position is east, let's say this is your kind of line, east is here, and you can see it moves towards the reference point and then away from the reference point. And that's the answer for this particular question. You can see that whenever we have a position time graph, we can easily extract the information about displacement, position, and also the average and instantaneous velocity. We weren't asked for instantaneous velocity for this. If they were, we would just find the tangent and then find the slope of the tangent. Now for the next question, it says for the following graph, determine the following. So first, let's say this is also good to two significant figures. Velocities at times 2, 4, 6, and 8 seconds. Okay, we can definitely do that. This is a velocity time graph. So velocity at time 2, velocity at time 4, velocity at time 6, and velocity at time 8. And that should answer this question. So velocity at time 3, this is a velocity time graph, so obviously we can read velocities from it. At time 3, the velocity is 3 meters per second. And it's in the direction of east. Since it's velocity, we need to make sure that we indicate the direction. If we were asked for the speed, we would not include the arrow and we will not include the direction, but the speed is still 3 meters per second at that point. Velocity at 4 seconds, well, that's right here. That's 2 meters per second east. Velocity at 6 seconds, right in here, that's 0 meters per second east. And I should just make my life easier. I'm going to make this one good to one significant figure. And finally, for the last one, at 8 seconds, we are at negative 2 meters per second east or 2 meters per second west. Okay, for part B, the change in velocity from 4 to 6 seconds. Okay, so at 4 seconds, we're here. And at 6 seconds, we're here. So the change in velocity from 4 to 6 seconds then is going to be velocity 6 minus velocity 4. I'm going to take east to be positive, and basically velocity 6 is 0 and velocity 4 is 2, and that will be negative 2 meters per second in the east direction. Note that we didn't really need to use an equation like this. We could simply just look at the graph and say velocity at 4 seconds is 2, and velocity at 4 seconds is 0, so the change in velocity here is negative 2 meters per second in the east direction. Then we need to find the displacements from 0 to 3 seconds, from 3 to 6 seconds, and 6 to 8 seconds. Okay, no problem. I'm going to erase this though, because it will make our job a little bit easier. Well, for the displacements, can be found by area between curve and time axis. So let's do that for the different time periods. I'll use different colors to signify them. So for part C, we're looking from 0 to 3 seconds. So that's this area over here. Okay, this area is a it's a square here, and the displacement from 0 to 3 seconds here is going to equal to that area, which is 3 times 3, and that's going to give me 9 meters, and it's in the positive direction, and it's in the east direction, so I'll leave that in. The next area is going to be area from 6 to sorry, from 3 to 6 seconds. So that's displacement from 3 to 6 seconds. And I have to look at the next area, which is here to here. I have a base value. Base here is 3. Height here is 3. So this is 3 times 3 divided by 2. And that's going to be 4.5, but I need it into two significant figures. So I'll write it as 4.5 meters east, and I will approximate it to 5 meters in the east direction. Okay, and then let's use red for this one. And the final area, I have a base of 2, a height of -2, and therefore for part E, my displacement from 6 to 8 seconds is going to be 2 times -2. I have to divide it by 2 because it's a triangle. And this will produce -2 meters in the east direction or 2 meters in the west direction. And this is fantastic. This kind of makes sense because if the object is moving in the east direction, if I had kind of my reference points like this, if the object is moving in the east direction, the displacement should also be in the east direction. This one is moving in the east direction. It's slowing down, but it's moving in the east direction. Displacement is in the east direction. In here, the object slows down to 0 and then starts moving in this direction. And as soon as it moves in this direction, displacement should be in the negative direction or the west direction. Finally, the question is asking us for the total distance and then the average speed. So I'm going to kind of move this up here so that we can finish the question. We have part F, which says the total displacement. The total displacement will be the displacement from 0 to 3 plus the displacement from 3 to 6 plus the displacement from 6 to 8. And these are all displacements, so I need to make sure my arrow is included. And displacement from 0 to 3, that was 9 meters, plus displacement from, the next displacement is, I'm going to put the exact value here, and then I'm going to make any possible roundings later. So this was 4.5 when I calculated it. Plus my final one, which is -2, and that's 6 to 8. I will add these up, and I will get 11.5, which I have to round up to 12 meters in the east direction. So this would be my final answer, and that's for the displacement. How do I find the average velocity for the entire, so this is for the entire trip? Well, all I have to do is I have to take the total displacement and divide it by the time it took. We know it took the whole trip 8 seconds, so we can use that, or we can, actually no, that's the only way. So I'm actually going to bring this up a little bit, and I'll do G here. G is going to be average velocity from 0 to 8 seconds is going to be the displacement from 0 to 8 seconds divided by the time between 0 to 8 seconds. That's going to be 11.5 divided by the total time, which is 8. And rounding my answer to one significant figure, this would be approximately 1 meters per second in the east direction. Now, to find the total distance, that's h, let's use a different color. For the total distance, I will do the exact same thing as I did before, except I will add the distances and not the displacement, so I don't put the arrow anymore. The distance between 0 to 3 was 9, and then I had 4.5, and then I had plus 2. So When I add all of them up, I will get 15.5, or rounded up to 16 meters in the, well, no longer need a direction for this, so it's just 16 meters. And to find the average speed, I have to take the distance, so I'll do that here. For the average speed between 0 to 8, I will take the distance from 0 to 8 and divide it by the time from 0 to 8. That's 15.5. Again, I use the exact value, not the rounded one, in order to get proper values. Divided by 2. Divided by 8, because it takes 8 seconds for the entire trip. And when I do that on my calculator, I will get 1.9375, and that should be rounded to 2 meters per second as my final answer, because I need my final answer to be one significant figure. Okay, there's one other question that we need to do, and that is to sketch the velocity time graph for the following graphs. Not a problem at all. I will draw some points where I'm going to draw some tangents, and then I'm just going to connect them. So, and I'll do the same thing for this one. Not drawing the best of lines. I don't think they're that vertical, but they, again, it's a sketch, and the beautiful part about a sketch that it needs to show the work nicely with all the information, necessary information, but it doesn't need to look pretty. So in this first case over here, my tangents at the first point looks like this. Pretty steep in the negative direction. This is not as steep, still negative direction. Tangent at here, 0 value. So this one, 0 value here, medium steepness, but in the negative direction. And here I have it as kind of much higher slope, but again, negative direction. And I can kind of connect them, and that will give me a sketch of the velocity time graph. For the next one, I'm going to do the exact same method. So I'm going to draw tangent. This is a pretty high value, and it's positive. And then another tangent. This tangent here, it has a positive value, but medium steepness. Right here, the tangent is right at 0. So I'll just put it at about 0. The steepness is medium, so somewhere here, but it's negative in terms of direction. And the steepness right at the very end for my tangent is, it is pretty steep, and it is also negative. The slope is negative. So then I would just connect the points, and I get something like this. When you're answering these types of questions, if you find the steepness to be much higher, so let's say here instead, and this one much higher here, and if your graph looked kind of like this, that's okay too, as long as it has the proper shape and that you're using the proper concepts of drawing the tangents and using their slope to come up with the velocity time graph. I hope that the video was helpful for you.